Hi, in this video we are going to look at balancing chemical reactions and a touch of stoichiometry, but most of it will look on balancing chemical reactions. The first few, the reaction is written for us, but we have to balance it. But then in some others we'll have to actually write the equation and balance it. So the first question says, in the equation below, 8 moles of hydrogen react with how many moles of P4? So I've got a chemical reaction. Oh, all my arrows turned to R's. That should be an arrow. So I've got some reactants on this side and products on, or a product on this side. And so that's a chemical reaction, reacting phosphorus with hydrogen and forming phosphorus trihydride, I guess. And they want to balance the chemical reaction. So balancing means I have to have the same number of P's on the left side as I do on the right side, and the same number of H's on the left and on the right. So when I take a look at it, initially this little 4 there indicates that I have 4 phosphoruses on this side, and I've got 2 hydrogens. And then here, this 3 only belongs to the hydrogen, so I'd have 1 phosphorus and 3 hydrogens. So when you look at it, it's not balanced. I've got 4 on one side of phosphorus and 1 on the other side, so I have to balance. When I balance the equation, I can only put numbers out front in the coefficient as opposed to being a subscript. The subscripts are there only to balance a formula or a compound, or sometimes, like in the case of hydrogen, like hydrogen and oxygen and chlorine and fluorine and nitrogen, all of those are diatomic, so when you write them by themselves, they always get a 2 on them. Okay, so to balance this, I'm going to start with the phosphorus. So I got 4 here, only 1 here. So it's logical for me to put a 4 here. And when you're balancing, you want to think multiply. So you don't want to think, well, I need 3 more. I want to see how many I have. So if I put a 4 there, then you multiply 4 by, there's just 1 phosphorus here. 4 times 1, that'll give me now 4 phosphoruses on this side. So my phosphoruses are balanced. But by putting a 4 there, that affects not only the phosphorus, but also the hydrogen. So to figure out how many hydrogens I have, I multiply the 4 by the 3, and that gives me 12 hydrogens on the right-hand side. So now when I look, and I've got 2 hydrogens on this side, not balanced, but I can balance it fairly easily by putting a number out front here that when you multiply it gives you 12. So if I put a 6 here, 6 times this 2 gives me 12. Now I've got 12 hydrogens on the left, I have 12 on the right, all balanced. Okay, so that's the balancing. Now to do the stoichiometry for this particular question, let me erase all my stuff below here. Now that I have a balanced chemical equation, now I can cross the river, and that's this spot right there. So in this particular question, they're saying I'm starting with moles of hydrogen, so 8.0 moles of hydrogen, and they want to know how many moles of phosphorus they're reacting with. So I want to know how many moles there. So in my question, I'm actually starting here, because this is what's given. I'm given 8 moles of hydrogen, and this is what's asked on this side. I'm going there. So I only have 1 step to go. So just 1 step. And I'll maybe do this one. So the step would be a ratio and proportion. So you write down what you have, 8.0 moles of hydrogen multiplied by, okay, now I'll use my ratio up here. So it's 1 to 6. So the one that I put on the bottom is the one I want to get rid of. So that's the hydrogen. So 6 moles of hydrogen react with 1 mole of phosphorus. So the moles of hydrogen cancel. So I'll go 8 times 6 divided, or 8 times 1 divided by 6, and I'll get 1.33333, etc. moles, rounding to 2 sig figs because of that number right there. There's 2 digits in there, and so I would round this to 1.3 moles. So when you balance the chemical reaction, It's critical because that step, that middle step, you have to have this ratio correct, otherwise you get that part wrong. And if you get that part wrong, if you have to do any other steps, they'll be wrong too. Okay, so next question. I've got, whoops. Here we go. So it says I have potassium chlorate decomposed according to the unbalanced equation, and then they ask the question. So I need to balance this chemical equation. So taking stock of what I have, 1 potassium, good. 1 chlorine, cool. 3 oxygens, 2. Now, when the numbers are 3 and 2 like that, you think in your head, you think common denominator. So the common denominator of 3 and 2 would be 6. So I want to get 6. So what number do I have to put in front of the oxygen there? If you said 3, you're correct. So if I put a 3 there, cool. So that gives me 6 oxygens on this side. But now I only have 3 on this side, so what number do I need to put in front of there? It's something that when you multiply by 3, you get 6. So yeah, it'd be a 2. Good. So now I've got 6 oxygens. But by putting a 2 there, now that gives me 2 potassiums and 2 chlorines. Over here I just have 1, but you're probably seeing that if I put a 2 there, now I'm going to have 2 potassiums and 2 chlorines. Equation's balanced. Again, that should be an arrow. Okay, now this question, they say 1.6 grams of that, and they want to know how many moles of KCl are formed. So how many moles of this? And they're giving me 1.9 grams of that. So this is a mass, so that means I'm going to be in Solidsville. And they want us to go to moles, so that would be Moledale right there. So there's going to be one step to do this, and a second step to get across the river. And that step to get across the river is what you need those numbers there for. Next question. Rusting iron, balanced equation below, or unbalanced. Let's take a look at it. Iron's not balanced. Oxygen, a 3 and 2. Oh, that's a 3 and 2, the 6th thing again. So if I put a 2 here, 6 oxygens. Put a 3 there, 6 oxygens on the left. There's my arrow. But now on the right, how many irons is that? 2 times 2 is 4, so I need to put a 4 there. There's my balanced chemical equation. And so when I do the ratio proportion thing to go across, I'll be using some of these numbers. Again, I'm starting with 1.76 grams of this, and it says how many grams of this will be produced. So I'm starting in Solidsville. I have to get to moles. I have to go across the river, and then I also have to go up to grams on this side. So that's a 3-stepper question, that one. Next question. Ethene burns. So ethene, I'll need to look up the formula for that somewhere. Your data booklet would have that. You can look it up. I think ethene is C2H4, I believe. Yeah. Okay, and if it says burns, then burns means it's a hydrocarbon combustion. So you react it with oxygen, and that produces carbon dioxide and water. Okay, there's my reaction. Let's balance it. With these, I always do carbons, and then hydrogens, and then oxygens last. So 2 carbons here, I'll put, and here there's just 1 carbon. This 2 only affects the oxygen. So there's just 1 carbon, so I need to put a 2 there. So 2 carbons, good. 4 hydrogens over here, what do I need to put there? A 2. So 2 times 2 gives me 4 hydrogens on that side. So carbons, hydrogens, balanced. Cool. Now let's check oxygens. So here, 2 times 2 would give me 4. And then 2 times 1, because there's 1 oxygen there. We usually don't write that 1, but 2 times 1 would be 2, so that's another 2. So altogether on this side I have 6 oxygens. So what do I need to put there to give me 6 oxygens? If you said 3, you're bang on. And then it looks like this one, how many grams of ethene reacted? So it looks like this one, you're starting with grams and you're ending with grams. That's another 3-stepper question. Try a couple more. Actually, a bunch more. I've got 5, 6, 7. Oh, I think there's 10. Anyway, ammonia is formed from its elements. Oh. Well, I know ammonia is NH3, and it's being formed, and so that'll be on the product side. And it says it's formed from its elements. So its elements are nitrogen and hydrogen. So over here I just write nitrogen and hydrogen. But then I realize that both nitrogen and hydrogen are diatomic, so they're never by themselves. They always come in buddies. So this will be N2 and H2. Okay, so now to balance. Nitrogen, I have 2 here, only 1 there. So I need to put a 2 there. So that'll give me 2 nitrogens, 2 nitrogens. Over here, I've got how many hydrogens? 2 times 3 be 6. So what do I need to put in front of that to make 6? 3, right. Good. Hexane burns. Oh, hexane. Hex, that'd be 6. So hexane, I think, is C6H14. I think that's the formula for hexane. And it's burning, so it burns in the presence of oxygen to produce, of course, carbon dioxide and water. Now, all these would have states like gases or liquids or something like that, but I'm not focused on that. I just want you to focus on getting the chemical equation right and then the stoich part of it. Okay, so I need to balance 6 carbons and only have 1 here, so I'll put a 6 there. 14 hydrogens, I only have 2 here, so if I put a 7, 7 times 2 is 14, good to go. Let's check oxygens. 6 times 2 would be 12. 7 times 1 would just be 7. So altogether that gives me 19 oxygens on this side. What do I put there? I guess you could just go 19 divided by 2. So you could just write 9.5 there. And that would be fine. And with stoichiometry, that would work perfectly too. So that would be correct if you wrote that as your balanced chemical equation. But typically, they don't like having decimals as coefficients for balanced chemical equations. And so what I could do is just go and times everything by 2. So I'll double this one to get 2. I'll double this one to get 19. Double this one to get 12. Double this one to get 14. If you want, we can check again. 2 times 6 would be 12. And here now I've got 12. 2 times 14 is 28. Here I've got 14 times 2 is 28. For oxygens, 14 times 1 would be 14 here. And then 12 times 2 would be 24. And 24 plus 14 is 38. And that's 19 times 2 is 38. So that would be balanced. Okay, so I'm doing all this writing on top of stuff, but hopefully that helps you as you're balancing things. Okay, let's try this next one. Let me move things up a bit. Oh. Let me move things up a bit. Oh, hitting the wrong button. Okay. Oh, and they actually give us the chemical equation this time. Good, that's an arrow. For the reaction below, yeah, whatever. Okay, I got to balance this. Okay, 1 calcium, 1 calcium, 1 carbon, 1 carbon. 3 oxygens, 1, 2, 3 oxygens. This isn't bad. 1 hydrogen, 2 hydrogens. Oh, I was so close. Why don't I put a 2 there? So 2 hydrogens, perfect. This gives me now 2 chlorines, 2 chlorines. Oh, I'm done. All I had to do is put a 2 there. Cool. Now this reaction, that's sort of a complex one. I wouldn't ever ask you to create that one on your own. The forming or decomposing or combustion, those are typically ones that you could do, or single or double replacement. We'll do a couple of those in a sec. Okay, so that one's done. Let's look at the next one. what volume of phosphoric acid is needed to react with sodium hydroxide? Oh, okay, so let's go. I'm reacting phosphoric acid with sodium hydroxide, and I have to come up with a reaction with that. This is a double replacement reaction. Specifically, this is a neutralization reaction. So with that, when you have groups like this, treat them as a thing that you're not going to break apart. And here's another one of those, a hydroxide. And you can look on your data booklet where the complex ions are. Any complex ions, when you're doing a reaction, typically they stay together. So when I do this reaction, this hydrogen is going to go and hang out with the OH. So that'll be an HOH. I guess I could write it as H2O. But it turns out when you're balancing, it's a little easier to write it as HOH. And then the sodium, get a different color, sodium will hook up to the phosphate. And I write the sodium first because it's a positive ion. We always write the positive ions first. So this will be plus Na and PO4. Now, I should have noted this with the HOH, or the water, as well. When you write the compounds on the right-hand side, you have to make sure they electrically balance. And hydrogen is a 1 plus, and hydroxide is a 1 minus. So those charges balance. That's why I can write it as just HOH. But sodium and phosphate, sodium is a 1 plus, and phosphate's a 3 minus. And so they're not electrically balanced, so I need to balance them. So what I need is I need to have 3 of these sodiums to hook up with the phosphate. So I put a 3 right there. So 3 of these positive ions would give me 3 plus, and then I have a 3 minus. Those are balanced, so life is good. But don't confuse that balancing of the electrical charges within a compound with balancing the whole reaction. Okay, so maybe let's do balance the whole reaction now. So let's start maybe, again, I'm going to treat this OH as its own thing. So there's one OH there and one OH there. This is good. But here I've got 3 hydrogens. And here there's just 1 hydrogen. Right, because I'm treating the OH as a group, so don't think of this as a hydrogen. You want to think of the whole thing as an OH. So if there's 3 hydrogens here and only 1 here, I need to put a 3 there. So that 3 hydrogens hooks up with this 3 hydrogens, they're balanced. But that gives me now 3 hydroxides. So here I only have 1 hydroxide, so I'm going to have to put a number out front here to give me 3 of them. So now I've got 3 hydroxides. But doing that gives me 3 sodiums. Over here, I have 3 sodiums. Life is good. Here I have 1 phosphate, and over here I have 1 phosphate. And so now my equation is balanced. Okay, this particular one, I didn't do these in the last questions, but once I've got it balanced, now I can do the stoich part of the question. This looks like it gives me, it says what volume of a 0.2 molar phosphoric acid. So here I have a concentration of 0.20 molar, and they want to know what volume of that is needed to react with 100 milliliters. So that would be, the volume is 0.100 liters, and the concentration is 0.10 of the sodium hydroxide. So they're giving me this information and they're asking me this information. So I'm starting with a liquid, and I need to go to moles of that sodium hydroxide, cross the river to moles of the phosphoric acid side. This is my sodium hydroxide side. And then I need to go to Liquidsville there, Liquidsdale there on the right side to get me my volume. So this again will be a 3-stepper. I like the 3-steppers. Next one, zinc reacts with hydrochloric acid. So zinc by itself, it's not diatomic, it's just by itself, reacts with hydrochloric acid, so HCl. And it's a single replacement reaction. So zinc, which is a positive ion, is going to come in and knock hydrogen out of the game. So zinc will come in and knock this out and hook up with the chlorine. So this will be zinc and chlorine together, plus then the hydrogen goes off by itself. And we know that when hydrogen by itself is always H2. Now I need to come back and look at this to see if it's electrically stable. Chlorine I know is a 1 minus, but when you look at zinc, zinc is a 2 plus. So in order for those to electrically be stable, I need 2 of these chlorines, because 2 of the chlorines will give me now a 2 minus, and 2 and a 2 plus, those cancel out. Okay, so I've written my compounds down now all correctly. Now let's balance the equation. So I have 1 zinc here and 1 zinc there. Good. I have 1 hydrogen, 2 hydrogen. Got to fix that. To do that, I'll put a 2 here. So that'll give me 2 hydrogens, 2 hydrogens. This also gives me 2 chlorines. But here, oh, I have 2 chlorines. Ah, good, so I'm balanced. Okay, perfect. All right, let us do one last question. Oh, and the stoich for this one too. This would be, they say, 25 mils of hydrochloric acid. So, this would be 0.025 liters and 4.0 molar, or moles per liter. And that, sorry, I've got people texting me. My mind went for a second. So that's my given stuff. And they want to know how many grams lighter will the zinc be. Oh, so they want to know how much of the zinc will react. And so they're wanting to know how many grams lighter, so that would be a mass. So I'm given this and I'm asked this. My given side will be my HCl, and that is liquid stuff, so I'm starting here. So I'll need to do 1 step to get there, 2 steps to get across the river, and then they want mass information, so that's solid, so I need to do that 3rd step there, so 3 steps. Okay, last question. Throwing some scrap iron, gold nitrate, cause of the gold metal precip, gold, what volume would react? Okay, so here I've got a chemical reaction, I got to balance it. This is a good one to show those complex ions again. Okay, 1 iron, 1 iron. Good. 1 gold, 1 gold. Here I've got 3 this number here tells me I have 3 nitrates. Again, nitrate is something that you can treat as a group. So 3 nitrates. On this side, I only have 2 nitrates. So there I've got the 2 and the 3. I've got to do the 6th thing. So I need to put a 3 there, because 3 times the 2 will give me 6 nitrates on this side. And then over here, since I have a 3 there already, what do I put up here? Right, 2. Because 2 times 3 will give me 6 nitrates. But then that messes up my other stuff, right? So let's fix the irons. So 3 irons, I need to put a 3 there for iron. Now I've got 2 golds, so over here I have to have 2 golds. Okay, and then just to do the stoich part, it says, what volume of a 0.5 molar gold nitrate solution? So volume, they want to know, and they give me the concentration as 0.50 moles per liter. Will react with 224 grams of iron metal. So this mass is 224 grams. So this is my given, and because this is where the question mark is, this is my asked side. So given side, asked side. Given, I'm given a solid, so I'm going to have to convert that solid into moles. And then I'm going to have to cross a river with my mole ratio, which would be a 3 and a 2 there. And then finally they're looking for volume solution information, so I'm going to Liquidsdale there. That'll be my 3rd step. So my 1st step would be using this formula. Moles is equal to mass over molar mass. That'll get me to moles. And then the next step will be my mole ratio. So whatever I get from this question, it'll be put there, and then I'm going to multiply by my mole ratio, and that'll be 3 moles of iron will produce 2 moles of gold 3 nitrate. Yep. Okay, that'll get me across the river to moles over there. And then my last step, third step, I'm getting solution information. So that's this formula. And they're searching for volume. So it'll be volume is equal to moles divided by concentration. You can look at this one just like we did the gas formulas. If you treat C as C over 1. So this is what I'm looking for. So multiply the other cross, n times 1, and divide it by concentration. All right, hopefully that helps you with the writing the balanced chemical equations.